Welcome to a new lesson. In the previous lesson, we learned about the job scheduling. In this lesson, we would look at shuffle and sort steps, which are core and hard to every MapReduce job. Every MapReduce job goes through the shuffle and sort phase. Map program processes input key and value, then the map output is sorted and is transferred to reducer, and this is known as shuffle. Let us see through a simulation run on how things happen. Map processes the input and the output is not directly returned to the disk, but is written to an in-memory buffer. Size of this buffer is decided by the property io.sort.mb. Its default size is 100 MB. As map writes in the buffer fills up, and when the buffer reaches a threshold, the threshold limit is by default 80%, a background thread will start writing the buffer contents to the local disk. Map's output continues to be returned to the buffer while the spill takes place. If the map has more of output, it may fill up the buffer, and in that case, map would be paused for a while till the spill empties the buffer. After spill is completed, map may again reach to the threshold, and in that case, another spill would be returned. Spills are written in round-robin fashion, and these are returned to the directory specified in the property mapred.local.dir. So there can be many spills before the last key value pair has been written by the map task. Each spill is partitioned and sorted by the key, and this is run through a combiner if the combiner function is designed for the job. This all is done by a background thread. Once map has finished to process all the records, all the spills are then merged to an output file which is partitioned and sorted. If more than 3 spills are merged together, combiner function is again run through the final output. Remember that the combiner functions can run many times without changing the final result. And combiner function reduces the size of output, which is advantageous as there would be less amount of data that would be required to be transferred to the reducer machine. If the map's output is going to be very large, it is recommended to compress the map's output to reduce the amount of data. This can be done by setting up the property mapred.compress.map.output to true, and compression scheme can be specified by the property mapred.map.output.compression.codec. After this comes the copy phase. There would be many map tasks running and they may finish at different times. As soon as they finish, they notify the job tracker or the application master, which asks the reducer to copy the result to the local disk. And so the partitions are copied by the reducer from the network. After this comes the sort phase, and in this phase, reducer merges the map's output, which are then fed into reducer to create the final result. The mechanism in sort phase is a little more involved. Let us look at the sort phase. In this phase, property which plays an important role is merge factor and is set by property io.sort.factor. Its default value is 10. It signifies how many files can be merged at one go. Let us understand this with a simulation run. Suppose if the reducer receives 30 files from different maps, then these can be merged in batches of 10, and in 3 rounds it would create the intermediate merged files, and in the final round it would be fed directly into the reducer. Just note that the merged files need to be sorted by the keys as well. To increase disk I/O efficiency, the actual algorithms behaves a little differently. It picks the first 3 files and merges into one, and then picks up the next batches of 10. In the final round, it would take the remaining 6 files and merge them and directly feed them into reducer. Doing it like this increases the disk I/O efficiencies. This wraps up our discussion in regards to shuffle and sort. See you in the next lesson.